we did the elimination part, right? So the day before we did substitution, yesterday we did elimination, and we're going to finish out 9.3 with graphing. So I'm going to skip. Yeah. One, on the record, I would like to go on because I am being recorded at the moment. You cannot bribe a teacher. That's not okay. Two, you got to make it really worth it because I could lose my job. No. All right. Solving systems using graphing. So the graphing is the third method. I would say if you had a choice, you probably wouldn't normally pick graphing unless you have graph paper so that it's 100% accurate. But what you're looking for is that the solution of the system can be found by graphing both of these equations, and then where they intersect is the solution, okay? So this is a lot easier if that solution is a whole number because it will fall right on a dot. It could sometimes be an in-betweener where it might be a half, okay, and then it's a little bit harder to tell. But if it crosses, like in this example, it crosses right there, I know that that is the intersection, and I can literally plot that point as 4, -1, and I know that's the answer. There are two special cases, just like with elimination and substitution, except that you're not adding these, so they don't cancel, like they cancel out. When you go to graph these lines, if they are parallel, they will never intersect. So if you remember from geometry, right, parallel lines never intersect. So if they're parallel and there's no intersection, then there's no solution. And if you end up with the same equation or an overlapped graph, then it's all real numbers. So depending on the type of numbers you have, when you go to graph them, they might actually be the same. You're overlapping a line, that means it's an all real numbers case. Yeah, like if it may not start the same line because we're going to solve these by putting them in a slope-intercept form this time. It may not look like it's in slope-intercept. I mean, it may not look like they're the same line at the beginning, but when you go to graph them, your y equals mx plus b will be the same, and that's the same line.
Slope, and they're going to be all real numbers.
Same slope and same y-intercept. If there's just the same slope and different y-intercepts, now they're parallel, and that's no solution. To number 12. Are we? Oh, like on the graph? Is that? I don't even know what number we're on. God bless you. All right, so the first one, obviously, it says solve the system by graphing. The first thing you want to do here is get these in a slope-intercept form. So I want to take this and solve it for y. So I would get -3y equals -2x plus 3, and then divide all the parts by -3, and I get y equals 2/3 x minus 1. I'm going to come back to it and graph it in a second. First, I'm going to solve the other one. So I'm going to take this one. I'm going to move this to the other side. So I get 6y equals 4x plus 6. Divide both sides by 6. And I get y equals, this would be 2/3 1. 2/3 x plus 1. So before we even graph these, what do we notice about them?
No solution.
Why?
Because the x-intercept thinking is the same, and the y is not, or is like that.
The slope, the x-intercept thingy, aka the slope. The slope is the same, but the y-intercept is different, right? So if you catch it from here, you already know this is no solution. If you are graphing it anyways, so we would start, I'm going to do the blue one first. Oh, I circled it in pink. I'm going to do the blue one first. Start at -1, right, because that's my y-intercept, and then my slope is 2/3. So up 2 and to the right 1, 2, 3, or down 2 and to the left 3. Either direction works. And then draw yourself your line.
Wait, can you repeat what Vanessa said?
The y, she said this, the x thingy, but she meant the slope. Mm-hmm. The slope is the same, right? Because look, they both have 2/3 x. The slope is the same, but the y-intercept is not.
I believe x thingy is the proper terminology.
Do you? All right, that's the blue one, and then the pink one, start at +1 and go up 2 and to the right 3, or down 2 and to the left 3, and then draw that line. And again, you're going to get two lines that are parallel, that are never going to intersect, which means this is a no solution.
Doing this with this, I need to figure out a form of sentence. Hold on.
Okay.
Okay. With like, the way we did it before,
Yeah, if you did it using another method, whether it's substitution or elimination.
is that, like, not necessarily more work is not what I mean, but I'm gonna use that work for trying to explain what I mean.
Yeah.
Like, would that be like more work because you'd have to do more steps?
Not necessarily.
But like, could you also use this method for those?
Yes.
things, even if you're not graphing them? No, because. never mind.
Only if it's one of your special cases will you see it before you graph it. So like, we only knew it was no solution because it was a special case. If I got to this point, which you'll see here, we'll do a different one, right? And this is not a special case. So I'm just gonna solve this one for y, right? So I'm gonna take the top one, I'm gonna solve it for y. So negative 3y equals negative 2x plus 3. Divide everything by negative 3, and I get y equals 2/3 x minus 1. Then I'm going to do the same thing, but with the second one, 2y would equal negative x plus 5, divide by 2. And I get y equals negative 1/2 x plus 5/2. So this, look at their slopes. They're not the same, right? This is not a special case. So this is, if I had the option at the beginning to use a different method, I would.
Because it's not a special case, so you wouldn't know that it's no solution.
Exactly. And then you have to graph it. And in my opinion, first of all, if you don't have graph paper, heck no, because you're not going to be 100% accurate. Second of all, of the three methods, it would probably be that's me. It would probably be my third choice. I would look at the top and I would say, all I have to do is multiply the bottom by negative 2 and I cancel out my x's, so I would probably choose elimination there.
Okay.
If you have the choice.
And for the first one, though, like, if we had the choice, couldn't we just multiply the top one by 2?
Yep.
And then you'd get.
And you'd end up with canceling all of it
Yeah.
except for the right side. It's going to end up saying 0 equals 12, and that's false.
So then that's how you know it was no solution.
Yep.
Is there any way you can solve the graphing ones using a different method? Like use a different method and then graph it? Or would that?
So you, like on your quiz, there's gonna be one that you're gonna be forced to graph. So you can graph it, and I would say you could check your answer using another method, but you're gonna get graded based on your graph.
Okay.
Does that make sense?
Yes.
Okay. So now I'm gonna graph these two. So I'm gonna graph the pink first. Negative 1 is my y-intercept, up 2 and over 3, down 2 and left 3, and there's my line. And then the blue one, this 5/2 is 2.5, so I'm going to start at positive 2.5. And my slope is negative 1/2, which means down 1 and right 2, down 1 and right 2. Or I can go up. Wait, did I go? Yeah. No, I didn't. Sorry, hang on. Those down 1 is here and right 2 is here. Down 1 and right 2 is here. And then connect those points. This crossing point, or this point of intersection, is my solution, which would be 3, 1.
Question.
Yes.
So, if it has like a plus, the y-intercept, that means we go up?
Yep.
Okay.
So although there was a fraction in this question, like when I graphed it, the answer is still a whole number, okay? Because it still falls exactly on that intersection. So folks from home, I don't know if you heard, but Juliana said, could we also use a different method? And I said, and you are going to get a question like on the quiz that says use the graph. So you're going to get a graph, and you're going to have to graph on the paper, on the graph itself to find the solution. That does not mean if you have extra time, you cannot check it using another method. You totally can. Or you could take that point and plug it back in.
So the solution is just where it intercepts?
Yep, which in this case is 3, 1. That top one is still the same, right? So I get y equals 2/3 x minus 1. The bottom one, when I move the x over, I get 6y equals a positive 4x minus 6, divide by 6, divide by 6, divide by 6. Y equals 2/3 x minus 1. This time the slope's the same and the y-intercept is the same. When I plot it, they would be the same line, both at negative 1, up 2 over 3, or down 2 and left 3. you would draw your line, and then you'd end up with the same exact thing for the second one, which means this is all real numbers. Good? Questions? For John? Yeah. Helen. Add this on. This is what it means by inconsistent, consistent, and dependent. So if it's consistent, it means that it has a solution, but it can be consistent independent and consistent dependent.
Is this British or something?
No, but this is on the, it asks what kind of, to describe the solution. So if you have one solution, then it's consistent independent. If it's the same line, if it was all real numbers, then it's consistent dependent. And if there's no solution, it's inconsistent. Okay? So again, it's gonna ask that in the homework. Okay.
Shifts above